All right, well, we're going to go through and talk about some inverse trig functions and filling up some blanks here. Going through and talking about, well, first off, inverse tangent function. Well, inverse tangent function, if you looked at my previous video, you recall that is basically everything is reverse. So you have to understand this, is that with the inverse tangent, the x is no longer the angle because it's been switched. Because when you have a tangent function, this is a angle, this is a output ratio. However, the inverse or arctangent, so sometimes it's written as this, okay, with that little -1. Does that mean reciprocal? Well, it means inverse. This is no longer the angle. This is now the ratio, okay? This is now, the output is the angle. And so what you have here is, you recall that because of that, normally a tangent graph has asymptotes at pi over 2 and negative pi over 2 and la 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 la. Okay, la 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 la. All right, we have this nice little looking graph like that. Okay, kind of like a cubic function going like so. Well, in this case, we no longer have that nice little cubic function with vertical asymptotes. We now have horizontal asymptotes. One that goes along pi over 2 and another one that goes along this one right here, which is going to be, all right, negative pi over 2. Okay, and so what we want to do is we want to figure out, okay, what are these outputs that we're looking for? Well, in this case, we also have to understand that with arctangent, we are talking about the first quadrant and the fourth quadrant for values. And so when we have this right here, we kind of have to think of in reverse when we want to find different points. So when this says, okay, what is the x value of arctangent when we have an output of pi over 4? Well, essentially, all we have to do is just figure out this value. It's looking for the ratio. Well, the ratio of when you have tangent of pi over 4, okay, what is that ratio? Well, that ratio is going to equal 1. 1, okay? And that's where we put 1 there. In the same token, if we're given an angle, that's our output. Well, how do we figure out that value? Well, if we take the tangent of negative pi over 6, okay, we know that that value, if you think about it, with the little unit circle, right here, that is going to be 30 degrees. Well, what's tangent? Well, it's going to be opposite -1, square root of 3. So tangent is going to be negative 1 over the square root of 3, or negative square root of 3 over 3. That would be our answer. We can continue on and talk about, okay, what is this value? Well, now let's go a little bit backwards. So that means if I have a ratio right here, and obviously it's below the x-axis, so we're having below the x-axis, so you're talking a negative angle. It has to be in the fourth quadrant because tangent is in the fourth quadrant for its inverse. We have the tangent opposite, it's going to be 1, then negative square root of 3. Well, that's going to be 60 degrees. So it's going to be negative pi over 3. Negative pi over 3 would be the angle. So once again, going back to way back in the early chapter of when we were talking about in chapter 9, talking about trig ratios, but understanding how these are opposites really can help you understand how to fill in different components of the arctangent, all right? Because they are inverses and relate very closely to what the tangent is. The same thing can be said with the cosine function, Because with cosine, if you recall, cosine is coming from this graph, okay? Because we're taking the inverse from when we started at 0, at 1 right here, and going all the way to pi, all right? Pi over 2 right there. And it's going to go like this. And now we're taking the inverse of this. And so once again, this is the ratio, and we're spitting out angles here, okay? Because it is the inverse of this. So this is just a regular cosine of x graph, where we plug in angles, we get out ratios. I know this can be confusing, but it just kind of has to understand what's your input, what's your output. Our cosine, input ratio, output angle. So when we look at this, if we're looking for this one, and we also know that we're going to be in the first and second quadrant when we're getting our angles. And so if I have right here, where do I have a cosine of -1 for the ratio? Well, the angle I need is going to be pi. In the same way as over here, if I have a negative ratio of 1/2, Well, if you think about the unit circle, that's going to be in the second quadrant, all right, because that's when x is negative. We have -1 and 2. Well, what's opposite of this? Has to be the square root of 3, all right, and so that's going to be pi over, actually, pi over 3, which is 60 degrees, with 2 pi over 3 because it's in the second quadrant, all right, because that's a reference angle, which is going to be 60 degrees, or pi over 3. Over here, now we're getting back into positive regions, so it's going to be the first quadrant. We have an angle of pi over 6. So what is our ratio? What's our x value? Well, in order to figure out our ratio, we can just simply do the inverse of cosine. If we take the cosine of pi over 6, that will give us our ratio. All right. And so right here, cosine, all right, pi over 6, first quadrant, which is 30 degrees. That's going to be 1 radical 3 and 2. Cosine is going to be square root of 3 over 2. Okay, and so going through this, wanted to help you out and understand, all right, how you can figure out these different points on our cosine and sine. You're simply just reversing your train of thought, in that you just always have to remember our cosine input ratio, get out an angle. So everything is just switched, all right, and reflected over this y equals x line. Hope this helps you out and understand a little bit more of how the trig ratios and the inverses are related to one another. All right, good luck and God bless in the rest of the problems.